In this section, we'll talk about relative maxima and minima and curve sketching. We'll learn techniques that will help us to sketch the graphs of functions. The point x1, f of x1 is a relative maximum point of the function f of x if there is an interval around x1 on which f of x1 is greater than or equal to f of x for all x in the interval. In this case, we say that the relative maximum occurs at x equals x1, and the relative maximum is f of x1. The point x2, f of x2 is a relative minimum point of the function f of x if there is an interval around x2 on which f of x2 is less than or equal to f of x for all x in the interval. In this case, we say the relative maximum occurs at x equals x2, and the relative maximum is f of x2. So that was quite a mouthful. If you have a function and it looks something like this, then this point here would be considered a relative minimum. And this point here would be considered a relative maximum. So basically, a relative maximum is just the greatest point in like an area, basically in an interval, maybe like, from here to here. And similarly, a relative minimum is just the lowest point on the graph, for an interval, maybe from like here to here or something like that. We say a function is increasing on an interval if the values of the function increase as the x values increase, that is, if the graph rises as we move from left to right on the interval. Similarly, a function is decreasing on an interval if the values of the function decrease as the x values increase. Example 1 says use a graphing utility to graph the function y equals 1/3 x cubed minus 2x squares. On what intervals is this function increasing and decreasing? So let's move over to Desmos. So I'm going to go ahead and enter in the function y equals 1/3 x cubed minus 2x squared. Okay, so if we take a look at this function, we want to take a look at these values here. And let's see, so everything before the x value 0, the function is increasing, and then the function is decreasing on the interval 0 to 4, and then everything is increasing again after 4. So the only place that it's decreasing is between the x value 0 and the x value 4. Everywhere else, our graph is increasing. So we want to say our function is decreasing on the interval 0 to 4, and then we'd say our function is increasing on the intervals -infinity to 0 and 4 to positive infinity. So that is where our functions are increasing and decreasing. It turns out that we can think about and kind of figure out when a function is increasing or decreasing based on the derivative of a function. So if f is a function that is differentiable on an interval a comma b, then if f prime of x is greater than 0 for all x in the interval a comma b, then f is increasing on that interval a comma b. If f prime of x is less than 0 for all x in the interval a to b, then f is decreasing on that interval a to b. Critical values are the x values of a function such that f prime of x is equal to 0 or f prime of x is undefined. The point corresponding to a critical value for x is called a critical point. So to kind of recap, a critical value is just an x value such that when you plug it into the derivative, it's either equal to 0 or undefined. Let's talk about relative maximums and relative minimums. If f has a relative maximum or a relative minimum at the x value x sub 0, then f prime of x sub 0 is equal to 0, or f prime of x sub 0 is undefined. And hopefully we can kind of make sense of that. So let's say, you have your x and y axis here, and you have the graph of some function, and it looks like that. Here, there's a relative maximum, and the reason that it's equal to 0 is because if you thought about the slope of the tangent line, whenever you have a maximum or a minimum, the tangent line is going to be horizontal. So here, the slope of this line, the slope of a horizontal line is 0. So that's why this part is happening. And then sometimes you have scenarios where your function may look something like this. So maybe it looks something like that. And here, this is a relative minimum. I'm going to abbreviate rel min for relative minimum. So there's a relative minimum there. However, there's not a tangent line because we have a cusp here. So it's hard to draw the tangent line because of the way that it's cusped there. And so here, if let's say this was some x value c, then f prime of c would be undefined in that scenario. Example 2 says find the relative minimum of the function f of x equals x squared plus 2x minus 8. And this is an example of a quadratic function. And so there's a couple of ways we can find the relative minimum of this function. The first way is we can factor this. So I'm going to use the x method, and I'll put the b value here and the c value here, and I want to try to come up with two numbers that add to positive 2 and multiply to negative 8, and those numbers are going to be 4 and negative 2. So that means that f of x factors into x plus 4 and x minus 2. And so if we calculate, or if we're trying to find the x-intercepts, we could set f of x equal to 0 and solve for the x values that way. And using the zero product principle, we would get x plus 4 equals 0 and x minus 2 equals 0. And then if we solved those equations, we would get x equals negative 4 and x equals positive 2. Now, if we thought about the graph of that, so this is a rough sketch, but here's negative 4 and here's 2. And so the graph of our function would go through these 2 points. And because parabolas are symmetric, the x-coordinate of the vertex is going to be exactly halfway between negative 4 and 2. And the number that lies exactly halfway between negative 4 and 2 is negative 1. So that means that our vertex is going to be down here somewhere, and the graph of our function is going to look something like that. Now, how do we figure out this y value? Well, I can just plug in negative 1 into the original function. So let me erase this here. I have my function here. So let me plug in negative 1, and I'll just plug it into the factored form. So I'd have negative 1 plus 4 times negative 1 minus 2. If we simplify that, we'd get 3 times negative 3, and that gives us negative 9. So this value here is negative 9, and we would say that the graph of f of x has a relative minimum of negative 9 at x equals negative 1. And that should be sufficient for a final answer. However, this is calculus, and it turns out we can actually use a derivative to figure out that value. And I think using the derivative is a little bit less work. So I'm going to go ahead and erase this. And if we take the first derivative of this function using the power rule, we'd get that it's 2x plus 2. And previously we said relative minimums happen when the derivative is equal to 0. So if we set this equal to 0 and solve it, if I subtract 2 on both sides, we get negative 2 is equal to 2x. And then if I divide both sides by 2, we get x is equal to negative 1. And that's not a coincidence. So this is the same value as this here. And then you can plug that back into the original function again and get negative 9. So setting the derivative equal to 0 is also a way to figure out a relative maximum or a relative minimum.